Hi, my name is Reza Affiq bin Roslan, matrix number 2019728667, and today I'll be presenting on my research. The title of the study is Comparison between different types of foot arches in relation to speed among the Malaysian Navy. First off, background of study. Running performance is influenced by many factors, including the initial strategy, step length, step frequency, biomechanics, and muscle composition. However, there are some studies that prove the types of foot arches of runners can actually affect running speed. The foot is composed of medial, lateral, and transverse arches. The foot is classified into three following categories depending on arc height. They are pes planus, normal, and pes cavus, which is the high arc. Most studies have found that runners with high arc foot have improved running speed when compared to low and neutral arc foot. Target population for this study is among Malaysian Navy from Royal Malaysian Navy Base in Lumut, Perak. They consistently involve in strenuous physical activities which requires them to have top-notch speed and agility. Next is statement of problem. There is limited research documented on foot biomechanics in correlation with running speed, especially foot arc height. Furthermore, relationship between types of foot arches and speed component among Malaysian has not been established, and thus it becomes a need for present study. From the evidence showed, this study is trying to prove which type of foot arch gives better results by highlighting the relationship between the types of foot arches and running speed of Malaysian Navy. Research objective: to identify which type of foot arches shows better result in terms of speed. The second one, to investigate the relationship between types of foot arches and speed. Significance of study. Findings from the study can be useful for the coaches, runners, and other researchers to contribute to theory and knowledge on how different types of foot arches affect speed. The findings should be able to help coaches to identify their athletes. Hence, it will be a solution according to restraining performance of athletes. Knowledge could be given to runners and sports practitioners on how their types of foot arches are related to speed performance. Moving on to literature review. Studies have been made on the arches of the foot as well as their effects on lower extremity function. Reza and Bart 2002 believe that the function of the foot depends on the shape of the foot to a significant extent. Sudhakar et al. 2018 in his study stated that the foot is classified into three following categories depending on the arc height. They are pes rectus, pes planus, and pes cavus, which is categorized into three using the morphology of the medial arc. In some countries, the mid-arc height of feet differs for adult male. Williams, 2001, in his study stated that runners with high arc and low arc feet with their different bony structures might exhibit very different lower extremity mechanics. There is sufficient evidence from previous studies to reveal that runners with high arc foot have better running speed when compared to low and neutral arc foot. Recent studies have found that people with higher arc height index tend to require a shorter time to reach the finish line. The statement was supported by Morris 1977, which concluded the high arc foot type was more beneficial for short distance runners. We proceed with methodology. For research design, the descriptive causal comparative research design will be used in this study. The rationale of the selection is because the information needed for this study is obtained from a sample that represents the population, which in this case, the Malaysian Navy. Causal comparative design will be used as this study seeks to compare the independent variables of types of foot arches and investigate the difference in running speed, which is the dependent variable that exists in between the different groups of high, medium, and low arc foot. The independent variable in this study cannot be manipulated. The results of this study will be analyzed from a one-shot data collection to control extraneous variables. Sample size for the study. The number of population is unknown, so to determine the sample size of the study, Cochrane formula 1977 will be used. The estimated sample size to be taken from the total population is 39, with additional 20% of the estimated sample to avoid unwritten rate and dropout. The total sample will be 46 samples. 46, yes. The standard deviation value used was referred from the previous journal of Sudhakar et al. 2018. Hereby is attached the formula used to get the sample size. When run off, we will get 40, an additional 20%, which is equivalent to 46 samples. The sampling technique. Purposive sampling of the non-probability will be the sampling technique used to collect the samples from the sample size estimated, as they cannot be selected randomly. Samples with BMI in a predetermined range will be selected to limit generalizability. Their BMI should be in between 18.5 to 24.9 to maintain the reliability of test results. Now I'll explain the instrumentation used in this study. To measure the type of food up, the wet test will be conducted. First, water is poured into a shallow pan that should be big enough to fit the food, while the water should be just deep enough to cover and wet all parts of bottom of the food. Subjects will then step into water with one foot, then carefully remove their food out of the pan. Next, they will step onto a flattened cardboard and put their weight on it. The food is removed from the cardboard and a photo of the footprint will be taken for reference. The process is repeated with subjects' other feet. Shown here is the procedures of the wet test. Next, to measure the running speed, 40-meter sprint test will be conducted. The test involves running a maximum sprint over a distance of 40 meters with time recorded. Subjects will perform a standardized warm-up before the test is conducted. The starting point will be positioned at 0.3 meter behind the gate, and subjects will start from a stationary position. After count of 3, subjects will accelerate maximally to the finish line as fast as possible. 2 trials will be given, with each separated by a 2 to 3 minute rest. The shortest time results will be used. The following are the data collection procedure. Before starting any test, informed consent forms will be distributed and should be filled by every participant. Part Q will be given as a screening to verify participants in good health and free from injuries, especially the lower limbs. Their BMI will then be measured and recorded to make sure that they are in a predetermined range. The type of food arc will be measured using the wet test. The test is to determine the subject's type of food arches before assigning them into different groups. After the food arc is measured, subjects will undergo a 40-meter sprint test, where they will perform the procedures of 40-meter sprint test, and the shortest time recorded will be used. The data collected will be arranged according to subject's type of food arc and then analyzed to identify which type of food arc shows better results in terms of speed. Lastly, the data analysis. IBM SPSS 26 will be used to analyze the data. To compare the types of food arches in relation to speed, descriptive analysis will be used to collect the data needed in order to analyze the mean. Descriptive analysis will be carried out using mean plus minus standard deviation, while inferential statistics will be conducted to see the difference between the groups of high, normal, and low arc food. Analysis of variance, ANOVA, will be used if the data distributions of the 3 groups were found to be normal, while Kruskal-Wallis will be used if the data of the 3 groups and the distribution were found to be non-normal. The data of all variables that have been collected will be compared to every group. To get the significance of the study, the statistical significance difference will be set at alpha p value less than 0.05 with alpha equals to 0.05. The references used in this study have been listed in the slide. That's the end of my presentation. Feel free to ask, and I would love to answer to your questions. Thank you very much.